Hello everyone, we're going to go ahead and get started on our exam 2 review. So we're going to start with our first question, question 1. As a nurse, part of your daily duties is to mix medications in the proper proportions for your patients. For one of your regular patients, you always mix medication A with medication B in the same proportion. Last week, your patient's doctor indicated that you should mix 90 milligrams of medication A with 81 milligrams of medication B. However, this week, the doctor said to only use 9 milligrams of medication B. How many milligrams of medication A should be mixed this week? All right, so this is a proportion question, so we're dealing with different proportions of certain medications. We've changed one of our proportions, so we need to change the other proportion within the same kind of, place as we've changed the first one. So let's go ahead and go to our notes and do this one. All right, so like we said, we have medication A and we have medication B. And so we would say that, last week we had this certain proportion where we used 90 milligrams of medication A and 81 milligrams of medication B. So we can say that we know this fact now. Last week we had 90 milligrams of med A and 81 milligrams of med B. And now this week, we don't know how many milligrams of medication A we want, but we know we want 9 milligrams of medication B. So we've had a change in proportion. So our proportion is a ratio of A over B. So if the ratio is A over B, then last week's ratio was medication A divided by medication B, so 90 over 81. And we're saying that this ratio should be equal to this week's ratio as well, where we don't know. Instead of writing a question mark, we're going to write X for how much we don't know for medication A, divided by our 9 milligrams of medication B. So with our ratios now established, they're set up and they're equal to each other, what we're going to do is we're going to cross multiply. So we'll write that out, cross multiply. So we're going to have 90 times 9 is equal to 81 times X. So we'll multiply this out, 90 times 9. We're going to get 810 is equal to 81x. We're trying to solve for x, so we're going to divide each side by 81. The 81s cancel over here on our right, and 810 divided by 81 is only different there by a factor of 100, or a 0. And so dividing 810 by 81, we should end up getting 10. So X, which was the amount of milligrams in medication A, we should have 10 milligrams of medication A. Ooh, that was weird then. And there we go. So that's how we can use proportions in order to solve for, anything new that we're trying to find when our previous information was based on proportions of anything. In this case, this was medication. So, all right, that wraps up number 1. Let's go ahead and go on to the next one. So for example 2, we're going to pivot a little bit. So we're rewriting the given standard form linear equation into slope-intercept form. We're going to identify the slope, the y-intercept, and the x-intercept, and then we'll sketch the graph of the linear equation. Our equation that we're using is 4x plus 3y is equal to -6. So let's go ahead and work this one out in our notes. All right, so like we said, this equation here, this is what's written in standard form. And we want this in slope-intercept form. For slope-intercept form is y is equal to mx plus b. So to get from standard form to slope-intercept form, we're going to solve this equation for y. So we have 4x plus 3y is equal to -6. So we want y by itself on the left, so we're going to send anything that's not y over to the right. So we'll go ahead and we'll subtract 4x from both sides. That will cancel on the left there. We'll get 3y is equal to, we want to write the x first since the format is mx plus b. So we have -4x minus 6. And now we want y by itself, so we're going to divide everything by 3. And that will cancel out the 3 in front of the y. We get y is equal to, and now -4 over 3, that doesn't really simplify, so we're just going to leave it like that, as -4/3 x minus, and 6 divided by 3 is 2. So luckily that worked out. So we get y is equal to -4/3 x minus 2. So we were able to turn this into slope-intercept form. So this is one of our answers here. Now we're being asked to identify the slope, the y-intercept, and the x-intercept. And then we'll sketch the graph of the linear equation. So we could certainly, to find the x and y intercept, we could certainly graph and then use the graph to find the x and y intercept. But when it comes to graphing, especially, we are going to graph by hand. So when it comes to graphing by hand, it's not exact. And so we're going to go ahead, we're going to algebraically solve for the x and y intercept. And then also we just needed to identify the slope. The slope is always going to be that number right there in front of the x. This is your m value, which is your slope. So we would get slope is going to be -4/3. That's one of our answers. Now we want our x and y intercept. So starting with the x-intercept, remember we want to let y equal 0 and solve for x. So in our equation, we have y is equal to -4/3 x minus 2. So we're replacing y with 0. We get -4/3 x minus 2. And we're going to solve for x. So to solve for x, we're going to add 2 to both sides. So we get 2 is equal to -4/3 x. Now we don't want this fraction here. We need to get rid of the fraction. So you do have two options. You can either multiply by the reciprocal, or you can just take it, 2 steps instead. So we can get rid of the 3 by multiplying each side by 3. So that'll get rid of our denominator. So 2 times 3 is 6. So now we have 6 is equal to -4x. Then we can get rid of our -4 by dividing each side by -4. So 6 divided by 4 would be -6/4. But 6 and 4 are both divisible by 2, so we want to reduce this fraction. So 6 is the same as 2 times 3, and 4 is the same as 2 times 2. So we can get rid of one of those 2's, and this gives us -3/2, which means our x-intercept will be -3/2, 0. Then we can find our y-intercept as well. Let's highlight that. Our y-intercept is a little bit easier. Our y-intercept, we let x equal 0, and we solve for y. So we have y is equal to -4/3 x, but now this is 0, minus 2. So anything times 0 is 0, so it's really just 0 minus 2, which is -2. So your y-intercept then would be 0, -2. Let me highlight that. All right, so there's our x-intercept and our y-intercept, and we can label those a little bit more if you would like. So this is our x-intercept. This is our y-intercept. So now we've gotten everything that the problem is asking us for. We changed our equation into slope-intercept form. We identified the slope. We found the y-intercept. We found the x-intercept. So now the last thing is to sketch the graph. So we're going to go ahead. We're going to draw out our coordinate plane here. And then we're going to go into graphing. So let's draw the coordinate plane. All right, so we have our coordinate plane here. Every one of these is going to be going by 1, so you can label. So we labeled those there, and then we're going to go ahead, we're going to put down the points that we know. So we know that we have an x-intercept at -3/2, 0, and a y-intercept at 0, -2. So our y-intercept is at 0, -2, which is this point right here. Then we have our x-intercept at -3/2, 0. So if we convert -3/2 into decimal, we know that this would mean the same as -1.5. So we're going to go ahead and estimate that point. It should be right in the middle between -1 and -2. So that's our x-intercept and our y-intercept. So in order to graph a line, really all we need is 2 points. As long as you have 2 points, you'll draw a straight line between those 2 points, doing it as best as you can. And then this will indicate the line y equals -4/3 x minus 2. So we're going to go ahead and draw our line as best as we can going between these two. So we want to connect our points, and then we'll just continue in that same motion there to estimate our graph. And this should be the line y equals -4/3 x minus 2. And there we go. We did this by hand, so it doesn't need to be absolutely perfect. It just needs to look somewhat accurate. And this looks somewhat accurate. We connected a line between the 2 points. And so we have our graph of our line there. So that's probably the easiest way to draw a line is when you find your 2 intercepts. You just draw a straight line through your 2 intercepts. That's the easiest way to draw a line. You only need 2 points in order to do it. So, all right, that was question 2. So let's go ahead and go back to our questions. All right, so then for number 3, we're going to solve each direct and inverse variation problems. So this is working with variation. So we remember from our lectures that with variation, we said that things react, differently with each other. And sometimes that's a direct variation, meaning that you're essentially going to end up multiplying some value in x and y. So when if x increases, y will increase. If x decreases, y will decrease. So that's your direct variation. And your inverse variation is the opposite of that. So if x increases, y decreases. And then if y increases, x decreases. So we see it switch there for inverse variation and direct variation. So we have 2 different ways of kind of doing these problems. They will tell us if it's going to vary directly or inversely. So we want to pay attention to that within our questions. We know we're going to have one of each here, so let's go ahead. So for A, we say the number of words Maria typed varied directly. So that's the key word there. It varied directly, so we know we're working with a direct variation. With the amount of time she spent typing. If she typed 285 words in 3 minutes, how long would it take her to type 1,710 words? So we've got our direct variation. Then for B, we have the frequency of a vibrating guitar string varies inversely as its length. Suppose a guitar string 2.8 meters long vibrates 3.6 times per second. What frequency would a string 2.6 meters long have? So that's our inverse variation. So we've got one of each, so we're going to go ahead and go into our notes to solve both of them. So starting with our direct variation for part A there, we want to remember that direct variation has an equation to it. Direct variation, we say that y is equal to k times x. So our direct variation is this value of k, where k is some whole number. It's not going to be negative or fraction, and it's some whole number. So we want to figure out, what k is going to be, and that'll help us figure out our variation constant, our constant variation. So with our variation here with y equals kx, I'm going to go ahead and just label what our x's and our y's are going to be so we know what we're kind of referencing to. So we're going to say that we're going to say that x is going to be the time, because x should always be your independent variable and time is independent. And y is going to be the number of words. K, our constant, will kind of be acting as the rate in which you learn number of words. But so we're going to go ahead and kind of put this all together. So if this is our equation and we know that x is time and y is the number of words, we're being told that Maria learns 285 words in 3 minutes. Now we don't know her rate, but we know that the 285 words, that's your y, and your 3 minutes, that's your x. So we can create our equation here. We get y's 285 is equal to k, the rate, which we don't know yet, is equal to, or k times x, which in this case is 3. So we have 285 is equal to k times 3, or 3k. You can write that as well. So we get, and you can rearrange this if you like to make it a little easier. We can say 3k is equal to 285, because you can switch an equation if you'd like. And so to find k, we can go ahead and divide both sides by 3 to solve for k. We get that k is equal to 285 divided by 3, which is equal to 95. So this is the rate at which she's learning words. So she's learning about 95, or sorry, not learning, typing. She's typing about 95 words per minute, which is very good. So this is 95 words per minute typed. So now we know the value of k. We didn't know the value of k before, but now we do. So now this is going to help us in order to find, how long or how many words, she can do it in as many minutes as she can. So to solve our new problem, we're saying that she's going to type 1,710 words at a rate of 95 words per minute, and we want to know how long. So that time we're talking about is the x. So we're going to go ahead and solve for x. So we're going to divide both sides by 95. And so dividing by 95, we get 18. So it would take her 18 minutes to type 1,710 words. So finding k wasn't necessarily part of our question, but it was an integral part in order to figure out the answer. So in order to do this type of problem, we need to figure out what the k is and then apply that to the actual question we're being asked. So there we go. That's a direct variation. Now we're going to go on to the indirect variation. So for this one, we were talking about a vibrating guitar string, and the frequency varies inversely with the length. So our indirect variation has an equation as well. Indirect variation is y is equal to k divided by x. So this makes it much more fractional in this case. We're going to say that, we're going to label y is going to be our frequency, because it depends on the length, so the thing that depends is y, and x is going to be the length. So we have our frequency, we have our length, that's labeled here. So we're going to go ahead and use the information that we know. So the guitar string vibrates 3.6 times per second at a length of 2.8. So we know the frequency, we know the length, and so we're going to go ahead, we're going to put this together with our equation y equals k over x. So y, we said, was frequency. So your frequency was your times per second, the vibration. So that's y. And then the length was your x. So your frequency, 3.6, is equal to, we don't know k, so k divided by your value of x, which is 2.8. So we want to solve for k. We want to get rid of our fraction, so we're going to go ahead, we're going to multiply each side by our denominator there, 2.8. So this tells us that k is equal to 2.8 times 3.6. So we can go ahead and go into our calculator and multiply that out. And this will give us 10.08. So it's almost 10, but we don't want to round too early. We always want to round at the end. So we have k is equal to 10.8. So that's the rate of k. So now that we know what k is, we're going to go ahead and use that for our next part of our question. What frequency would a string 2.6 meters long have? So our frequency, we're looking for y in this case. So we have y is equal to, and now we know what k is, 10.08, divided by x, which we're now saying is 2.6 meters. So our frequency is going to equal this value. So we go into our calculator, divide 10.08 by 2.6. And in this case, for this type of question, it doesn't state it here, but we're going to go ahead, we're going to round to the nearest hundredths. So that's the 2 decimal places there. And so when we round that, we're going to get 3.88. That's going to be our frequency. And there is our answer. Then we'll highlight our value for k as well. We had to find that. So there we go. So that's how we see different things in very inversely. That's with the equation that we use, and then kind of working through those types of problems to find an answer. So all right, let's go ahead and go on to the next question. For question 4, we're going to solve and graph the following inequality. We have negative 18 is less than negative 2x minus 6 less than 0. So we're going to go ahead and graph this one, and we're going to solve and graph this one together. So in order to solve this is our compound inequality. So in order to solve our compound inequality here, we need to solve for x. And the compound inequality kind of stands in the word for and. So we've got negative 18 less than negative 2x minus 6, and negative 2x minus 6 is less than 0. So the compound conjunction here for our inequality is kind of working as the word and. It's basically a 2-part inequality. So anything that we want to do to solve for x, we just need to do to both sides of the inequality, the one all the way to the left and the one all the way to the right. So for example, we want to go ahead, we want to get rid of the minus 6. We're trying to solve for x. So we're going to add 6 to both sides. That's it. Really, we're adding it to every side. We're doing all 3. So in the middle, and then on each end. So negative 18 plus 6 is going to be negative 12, less than negative 2x, less than 6. So we want to solve for x, so we're going to go ahead and we're going to divide by negative 2. When we divide by negative 2, we're dividing by a negative number. So we know that whenever we divide by a negative number, the sign has to flip. There are 2 signs in this case, so they will both end up flipping. So we'll divide by negative 2 here, and on each end. So negative 12 divided by negative 2 is going to be positive 6, and our sign will flip because we divided by a negative number. And we have x in the middle there, and then 6 divided by negative 2, our sign will flip once again, So it changes direction, and we get that 6 divided by -2 is -3. So we have, if we read this out now, we say 6 is greater than x, which is greater than -3. So when we graph our answer, we did solve it here, so this is one of our answers. But now we're going to graph. When we graph, we just want to make sure we have our important numbers on here. So we want to make sure we have -3. We also want to make sure that we have +6. So let's go ahead, we'll make that 0, we'll make this -10 and 10, and then we'll just fill in everything else. All right, so 0 is in the middle, we have -10 all the way up to +10. So we're saying that 6 is greater than x. We can also read this backwards as well. X is less than 6. We know that for a fact. And then we also know that x should be greater than -3, or -3 should be less than x. So this is a compound inequality. Whenever we have compound inequalities, we know that they will connect. So we connect them together. So we want to make sure that we draw our circles. They're going to be circles because we have less than, or we have greater thans really. But we have our strict inequalities, so they're circles. If they had the or equal to, we would fill in those circles, but they do not have that. So we'll do our open circle here. So we'll have one at 6 and one at -3. And now we're saying that x will exist anywhere in between -3 and 6 because x is less than 6 but bigger than -3. So we just want to color in everything in between. Remember, you can kind of make like a wavy line, or you can just color it in much darker. We have nice different colors here, so it's very easy to see, but if it's not, it might be a good idea to do a wavy line. There we go. And so there we have it. We have graphed as well. So when you're solving a compound inequality, you just want to remember to do whatever you're doing in the middle, you want to do to both ends. And that does include if you are using a negative number and you have to divide by a negative number. That does change your signs, but it really doesn't change much about your graph. Your graph will always end up with a compound inequality. Your graph will have the connection between those 2 points, where if you had the disjunction, where if it said or, it would say, it would have one inequality or another inequality. Those always face away from each other. So you want to keep that in mind when working with specific types of inequalities. So let's go ahead and go on to the next question. Circle has a radius of 6 millimeters. What's the exact and approximate circumference and area of the circle? We're going to round to the nearest hundredth if we need to. So we have our picture here. We have our circle. We see it has a radius of 6 millimeters. So our circumference and our area of our circles have specific formulas where they both use the radius. So we'll be able to plug those in. So, all right, let's do this one together. All right, so for example 5 here, we've already stated that we have specific formulas for the circumference and for the area. So the circumference of the circle will be equal to 2 pi times the radius. This is also the same as being pi times diameter. In this case, we only have the radius, we don't have diameter. We could find diameter, but it's not exactly necessary, so we don't need to. One important thing that's always good to remember, though, is that 2 times the radius equals the diameter, which also means diameter over 2 equals the radius. Good things to remember. So we have our circumference of our circle should be 2 pi r, 2 pi times radius, and our area is equal to pi r squared. There is no equivalent version for area in diameter, although we could technically still plug in diameter. It would be diameter over 2 squared. So for area, it's best to find what the radius is first and then plug that into your function. We have 2 parts of this question. We want the exact and the approximate circumference.
The exact calculations here means that you will leave it in terms of pi. So when we write this out, we'll have our circumference will be equal to 2 times pi times our radius, which we said was 6. We can simplify this by multiplying the 2 and 6 together, and this gives us 12 pi. And we leave it like that. That's what exact means leaving it in terms of pi. This is exactly correct. There are no roundings that would approximate the area. Now we can find, that was the circumference. Now we'll find the area. So the area we said was pi times a radius squared, which will be 6 squared. 6 squared is 36 times pi. So our exact circumference would be 12 pi, and our exact area would be 36 pi. Now, with approximate, it means we are going to actually plug this into our calculator and solve. So approximate values are what we actually plug into calculators. We already know that our circumference is 12 pi, but we're actually going to plug into our calculators 12 times pi. Then we were told to round to 2 decimal places. So we want to make sure to do that. So come out to about 113.10. One thing that was slightly forgotten here was to add back on our units. For circumference, we only have our radius one time, which means our units will be the same as the radius. So for our circumference, we would have 12 pi millimeters, or approximately 113.10 millimeters. Then for the area, we have 36 pi, which we will plug into our calculators and do 36 times pi, which will come out to about 113.10 will be the area. That is 36 times pi. That was an error on my part. So 36 times pi is 113.10. And when we calculate area, we took the value of our radius and we squared it, meaning that it will have the units of our radius squared. Same thing over here. This would be millimeters squared. Then for our circumference, which we said was 12 pi, 12 times pi in our calculator should be 37.70. That is the actual value of circumference and the area. We plug them into your calculators correctly. So there we have it. So always want to remember exact is going to be in terms of pi, approximate is actually plugged into the calculators and calculated out and rounding off to as many decimal places as you are being asked for. For us, it was the nearest hundredth, just so happened that both of them ended with a 0 in this case. But there we go. So those are our answers for problem number 5. So let's go on to problem number 6. For problem number 6, we have that Layla is staining the wooden floor of a court. The court is in the shape of a rectangle. Its length is 51 feet and its width is 32 feet. Suppose each can of wood stain covers 102 square feet. How many cans will she need to cover the court? So in this case, we're covering the entire portion of this rectangular court. So if we're filling in everything within the rectangular shape, we're really finding the area. This is also indicated by the fact that the wood stain covers 102 square feet. Square feet is, or square units in general, is referred to as area or measures of area. So we need to find the area of the court and then see how many cans of wood stain that Layla would need, knowing that it needs 102, or it covers 102 square feet. So let's go ahead and do this one together. All right, so we have our court here. It's in the shape of a rectangle. We draw this out as best as we can. So here's the court. Maybe it's, basketball or probably something along those lines. So we have our court here. We're saying it's 51 feet long and 32 feet wide. So we really need to find the area of the court. Area, we say, is length times width, or L times W. We have that the length is 51 and the width is 32. So the area of our court is really going to be 51 times 32. They're both in feet in this case, so when we write our answer, it'll be in feet squared. So we'll go ahead, put in our calculators, 51 times 32, which should be 1,632 feet squared. So that's the area of the court. Now we want to know how many cans of wood stain that she'll need. We know that every can covers 102 feet squared. Of the court. So the number of cans she'll need will be equal to the area of the court divided by the area of the stain. So the area of the court we said was 1,632 feet squared, and the area of the stain is 102 feet squared. Now in this case, we're just finding a number, so our units are canceling each other out. And we'll divide 1,632 by 102, which gives us the value of 16. So there'll be 16 cans will be needed to stain the floor of the court. So, all right, that wraps up example 6. Let's go on to example 7.
So for number 7, once again, we're solving for x, but this is a little bit of a different type of problem now. So we have x minus 3 over x minus 4 over 8 is equal to negative 4 over x. So we're going to try to solve for x. Each one of these is a different type of fraction, which can be difficult to work with. So we're going to work on this problem by clearing the fractions right away and then solving whatever is left over. And we'll make that a little bit easier. All right, so let's go ahead and do that in our notes. All right, so like we said, the easiest way to solve for x in this case is to clear the fractions. So that's what we're going to do. We're going to clear the fractions by multiplying each term by the least common multiple, or least common denominator. So we clear the fractions by multiplying each term by the least common denominator. So your least common denominator is basically the smallest thing that is divisible by every denominator. So in this case, our denominators are x and 8. We have another x here, but it's really just a copy of the x. So really we want the least common. If you're just working with single numbers or variables, it's the least common multiple. But when you do have a fractional setup like this, it is the least common denominator. So least common denominator of x and 8 is really just going to be x8, or x times 8. So since we have a variable and a number, the least common multiple or least common denominator is typically just going to be the number times the variable. But for example, if you had like a 3 in there, you would need the smallest thing that's divisible by x, 8, and 3. And so that would create a bigger number. But so we want the smallest thing that is divisible by x and 8. That would make x times 8. So our least common denominator here is going to be 8x, x times 8. So we're going to clear the fractions by multiplying every one of our terms by x, 8x. There we go. Words. So we've got x minus 3 divisible by x, 4 over 8, and negative 4 over x. So every one of these terms is going to be multiplied by 8x. Now, they're all fractions, and we're multiplying by a whole term. So 8x is really the same thing as saying 8x over 1. And then you can multiply straight across or cross cancel. So we can cross cancel our terms now. So we've got an x here and here, so we can cross cancel that. In our second term, we've got an 8 and an 8, so we can cross cancel that. And then in our last term, we've got our x and our x, so we'll cross cancel that. Now whatever's left is going to multiply into the inner term. In our denominators, either things have been canceled or you have ones that are left over, so those will all simplify down. You don't need the ones anymore. So we're going to have 8 times x minus 3 minus x times 4, which will be 4x, is equal to 8 times negative 4. And now we have a much simpler type of problem, which we can go ahead and solve. So we have 8x minus 8 times 3 is 24. X times 4 is 4x. And 8 times negative 4 is negative 32. So we want to combine our like terms and solve for x. So we've got 8x, that was the wrong thing. We've got 8x and negative 4x. We also have negative 24 and negative 32. So we want to combine our like terms, our highlighted terms. So 8x minus 4x is going to be 4x minus 24. It's equal to negative 32. We're trying to solve for x, so we're going to go ahead, we're going to add 24 to both sides. So we get 4x is equal to negative 32 plus 24 is negative 8. So then we go ahead and divide both sides by 4. Cancels out on the left there. And negative 8 divided by 4 is negative 2. And there we go. We have solved our equation. And the key thing that we had to do here was clear the fractions. So we cleared the fractions by multiplying everything by the least common denominator, which happened to be 8x. Then we canceled out everything that we could and multiplied everything together in order to get a simpler equation that was easier for us to solve. Now, another option that you could have taken is that you could have brought everything once you found your common denominator, combined everything into a single denominator, but that does take a lot of extra work and you'll still have to do things like clearing the fractions in the end anyway. So the option's up to you. If you know that method and you like that better, then by all means you can use that. But clearing the fractions is the one that I personally recommend. All right, so let's go ahead and do our last one. This will be our last one, number 8. So number 8, we want to solve the system of linear equations. We have a linear equation here. We've got x minus y equals 2 and 2x plus 4y equals 28. Now, for example, if this were given to you on a test and you're told to just solve the system of linear equations, you will not have a graphing calculator available to you. So while this doesn't say by using the elimination or substitution method, that is kind of implied. You don't have a graphing device in order to graph these two equations, so instead we're going to use the substitution and elimination methods. And we're going to show both so that we can, practice each one, and you can decide which one you like better. So we're going to solve the system of linear equations with the substitution and elimination method. So let's go ahead and go to our notes. All right, so we're going to go ahead, we're going to start with the substitution method. The substitution method is the one I usually recommend if you can't decide which one you like more. The substitution method is very methodical. It's always the same steps, but it can lead to fractions, which can be not fun. But the elimination method, while shorter, it takes more creativity. So it's got, bonuses and, minuses for both. So starting with the substitution method, remember your first step is to solve one of your equations for one of the variables. So this is equation 1, this is equation 2. So you solve one equation for one variable. You're always just looking for whatever looks easiest. What's going to have the least amount of steps? So between equation 1 and 2, equation 1 is a little easier because it doesn't have coefficients in front of x and y. So we're going to solve equation 1. And now we have to pick a variable, so we pick x or y. Now, they're both fairly easy, so either one is good, but x is just a tiny bit easier. Y has a negative in front of it, so if you solve for y, you'll have to get rid of the negative. Just a little bit of an extra step. It's really not bad, so if you do decide to solve for y, then it should be good. But we're going to go ahead, we're going to solve equation 1 for x. We've got x minus y is equal to 2, so we're going to go ahead and solve for x by adding y to both sides. So we get x is equal to 2 plus y. So now that we have that, we're going to replace x in equation 2 with what is equal to 2 plus y. So we're going to replace x in equation 2 with 2 plus y. So equation 2 is 2x, but instead of x, it's 2 plus y, plus 4y equals 28. So we're going to go ahead, we're going to solve this for y. So we're going to multiply out our 2 here. So 2 times 2 is 4, 2 times y is 2y, plus 4y is equal to 28. So 2y plus 4y is 6y. And we've got this 4 here, so we're going to get rid of the 4 by subtracting 4 on both sides. 28 minus 4 is 24. So we get 6y is equal to 24. We'll divide by 6 on both sides. And 24 divided by 6 is 4. So we know that y is equal to 4. So we want to solve for x. We need both. We need x and y. So we need to solve for x. So we can solve for x by replacing 4 for y in the, and we ended up at step 1, we ended up with this equation right here at the end. We're going to call that the starred equation. So we're going to replace 4 with y in our start equation there. X equals 2 plus y. Y is 4. So x is 6. Now typically, when we write our answer should look like an ordered pair. So we should get x comma y with parentheses. So x is 6, y is 4. So we should get 6 comma 4. And there we go. So that's how we can find our answer using the substitution method. Now we're going to go ahead and use the elimination method. Now the elimination method is a little bit shorter, but it requires some creativity and manipulation, so if that's not something you're comfortable with, I highly recommend the substitution method. But so for the elimination method, your first step is to manipulate your equations in some way so that one of your variables, x or y, ends up with opposite coefficients between equation 1 and equation 2. Opposite coefficients are the same number, but one is positive and one is negative. So for example, equation 1 doesn't have any coefficients. That will make it very easy to manipulate. And equation 2 has coefficients. So we want to try to make equation 1 have the opposite coefficients as equation 2. So equation 2, the coefficient of x is 2, and the coefficient of y is positive 4. Positive 2 and positive 4. So that means that we need to make equation 1 have the coefficient for either x should be negative 2 or y should be negative 4. Now, y is already negative, so multiplying equation 1 by 4 is a really good option. Or you could multiply by negative 2. So it's kind of up to you. If you're comfortable with using negatives, I'd recommend multiplying by negative 2. But if you don't mind a slightly bigger number, then I would pick positive 4 to match up the y's in that case. Either way, it's really just subjective. So let's go ahead, let's multiply equation 1 by negative 2. So we're going to multiply equation 1 by negative 2. So we're going to have negative 2 times everything in equation 1. So we're going to distribute negative 2 there. So negative 2 times x will give us negative 2x. Negative 2 times negative y, that's a double negative. So it's going to end up being positive, so we're going to get plus 2y. Is equal to negative 2 times 2 is negative 4. So this is our new equation. We're going to add this equation to equation 2. 2x plus 4y equals 28. So we're going to go ahead and add these together. Negative 2x and 2x will cancel each other out because they're being added. Then we have 2y plus 4y is 6y. And negative 4 plus 28 is 24. So we ended up kind of with the same thing as we did earlier. If you had solved for x instead of y, you would have gotten something that looked a little bit different. But your answer should be the same either way. We divide by 6 on both sides. We get y is equal to positive 4. Step 2 was to add them together, so that was step 2 there. And then lastly, step 3 is just to substitute 4 in for y in either equation 1 or equation 2. It doesn't matter which one you choose. Let's go ahead and do equation 1. That one's a little bit easier. So in equation 1, so we've got x minus y equals 2. So x minus 4 equals 2, so we add 4 to both sides to get x equals 6. And just like before, you want to write this as an ordered pair, so 6 comma 4 would be your answer. So no matter what method you choose or whichever steps that you choose in a certain order, your answer should always be the same. So this is a type of problem where it can look very different from someone else's. There's many different ways to arrive at the exact same answer. So your process may not look exactly the same, but as long as your answer was the same, that's ultimately what mattered here. And we can definitely see, yes, the elimination method was quite a bit shorter, um, but took that manipulation, which can be not so comfortable for lots of people. So, all right, that was our last question, question 8 there. So that wraps up our exam review, and good luck on exam 2, everyone.